Hello guys, good evening. This is the first video. Let us have a look at how to do this particular continuous beam where you have a cantilever, a fixed support with a UDL of 6 kilonewton per meter and then a UVL with mid load as the maximum with 8 kilonewton per meter and again another UVL of 10 kilonewton per meter, and there is an overhang portion with 50 kilonewton of point load at the tip of this overhang. Okay, and assume the cross sectional dimension 450 into 200 mm. All the units over here, this beam spans I have taken it in meters. Let us solve this using the StatPro. Analyze this using StatPro. I will just go to the StatPro screen. I will start with the new project. I will take this as a space structure. In fact, I need not to take it as a space structure. It can be a plane. Why? Because it's a two-dimensional structure. So I will save it as under practice. I will save this as continuous beam. Okay, I have taken the unit to be meter and kilonewton. I will say next, and I will say add beam. You can go with add beam or you can go with open structure wizard. Right now for this project I will go with add beam and I will say finish. Okay, so this is ready. Now I will just have a look at this. So one node is at 4, 0, 4, 10, 13 and 15. 0, 10, 4, 13 and 15. So I will just edit the grid. I need to increase the grid to some 15. I will make it to 16. Then I will say okay. So 0 to 4 and then I just need to check again. 4, 6, okay, 0 to 4, 4 to 10, 10 to 13, 13 to 15. 0 to 4, 4 to 10, 10 to 13, 13 to 15. Okay, so these are the beams that I have to take. I will just close this grid mode. So the beam is ready. I will take it to the front view. You can see the front view. Okay, so my under the modeling, the basic geometry of this particular beam is done. I will go with a general. Under that property, define a property. So it's a rectangular beam. It's in meters. So I will take the depth to be in 0.45. So 450 mm. Just have a look at the question again. 1 second. Have a look at the question. So it's 450 by 200. Okay, so 450 is the depth and the width is 200 mm. So 0.2. Material I will take it as concrete. I will say add, close. So use this to assign it to the complete all the beams assigned here. So I have assigned it to the complete beams. Then I will go with the support. I need to create a support. So first is fixed. At the left hand I have fixed, and again I will create one pinned, and again I will check what else the support. One pinned, and there is a roller too. Let me create a roller also. So create. I don't have a direct roller, but I can take enforced butt or fixed butt. I will go with fixed butt rather than enforced butt. You can take either of the. I will go with fixed butt, not an issue. So which I need to release? I need to release fx, mx, my, mz and fz, but not fy. Fy is restrained. Everything else is released in a enforced butt. So that's nothing but the roller. So I will just say add. Let me start giving that. So there is a nodal cursor. So I will select all the nodes. So here is the fixed support. Use cursor to assigning. I will just assign it over here. Then I will take the next one. I need to assign it through the other points. Okay. Then the last support will be the roller support. Right. Then I will go with the supporting is done. Property support is done. I will go with the loads. I will just add load cases. I will say add. First one is I will add the dead load, which is the self weight of that particular beam. So I will term it as dead load. I will say add. Then I will take the live load, which are all the loads given over there. I will call them as live loads just for an instance, but that's not actually the thing. But right now to solve this problem, I will add it like this. So dead load, I will say add. Again, I need to add the self weight as the dead load in global y direction. So it should be perpendicular down, so y direction. Downward negative, upward positive. So downward I am taking. All the loads should act towards the gravity, so I will take -1. So add, close. So this self weight will be there for all the components of a building. So I will assign to the view. So there are 4 options of assigning. I will apply it to the complete view, assign, yes. Now under the live load, I have different loads. One UDL, 2 UVL and a point load. UDL is 6 kilonewton, UVL is a triangular load of 8 kilonewton. So let me take the UDL first. So under the live load, I will just say add. I will go with the member load uniform force of -6 kilonewton, which is acting downward from 0 to 4 meter. The starting point of this is D1, ending point is 4 meter. So on the beam it is 0 to 4 in the global y direction, therefore minus y. Here you can see on the left bottom, upward positive, downward negative. So this is the y axis, so it should act downward, global y. So add, close. You can apply this load to check whether it is correct. Assign to the, I just need to click on this. Use cursor to assigning, I will just click and apply. Then again I will click on the live load. Second load, what I need to apply is a UVL of 8 kilonewton, a triangular loading. Let me apply this over 6 meters. So let me add. So again, under the member loads, you have linearly varying load. There are two types of linear variation. I will go with the second one, global y direction. So this is W2. What is the intensity? The maximum intensity at the middle is -8. So sorry, -10 I think. 1 second, let me check back. So it's 8 kilonewton over a span of 6 meters. Okay. So it is 8 kilonewton. Okay, -8 kilonewton per meter. I have taken W3 as this particular load. So I will say global y direction. I will say add, close. So click on the load. Use cursor to assigning. Click on the load where it is required. Again, go to the live load. Add. Again, member load. Again, linearly varying load. Now it is a triangular load. It should start from 0 and end at. So it is 0 to 10 kilonewton per meter over a span of 3 meters. So it should end at 10 kilonewton per meter. So again, it's in global y. Add, close. So again, take this load. Use cursor to assign over here. Sorry, I have forgotten to take negative sign. Just have a look over here. I will take the negative sign. If it is positive, it is applied towards positive direction. I will just say change, close. Now you can see that has been applied properly. Again, live load, add, member load. There is a uniform concentrated force. What is the intensity of that concentrated force? 50 kilonewton, which is applied at the end of 2 meters. So minus 50 kilonewton. So D1 is the distance. So it is 2 and D2 will not be coming into picture, global y direction. So add, close. So again, click on this. Use cursor to assign and click on the assignment. Okay, done. So all the loads have been applied. Now I will go with the commands, analyze, perform analysis, no print, and say OK. Then analyze, run analysis. Save. Guys, remember, when you are using the older version, you need not to get any warning or note or error. So if you are getting, you can clear them off. Check back how can you clear them off. Okay. So let me go to the post processing mode. I think most of you have seen the what is that file. You have two types of loading over here, dead load and live load. For what you need to see that, you can see. You cannot see it for the envelope. Envelope you can see for the bending moment and shear force. So Fy will give you the shear force and Mz will give you the bending moment. To view the values, I will go with the results, view values, beam results, and what is this bending moment, right? So bending maximum I need. If you want it at the ends, if you want it at the midpoints, you can annotate. So annotate, close. You can see the bending moment at the fine. Okay. So I don't want this bending moment. I want the shear force. Click on the shear force. Again, go to the results, view values, beam results. I want the shear. So where is shear? I want the maximum shear. Annotate, close. You can see the maximum shear. Now I don't want both. I want the deflection for the live load. Here is the deflection for the live load. You want the deflection for dead load. You can see the dead load deflection. You can ask me, sir, how to combine this? How do we get an envelope? So envelope is a different concept. We will not get the deflection for envelope. We will get the load combination for a deflection. So we can combine these two loads and represent it as one. For that you can get the deflection. Okay. So this is how you will get it. Fine. So how to make a report? Very simple. I told you, right click, take a picture. So I will name this as deflection diagram. So say OK. Then I am not taking all the pictures. I am just showing you the report. Then file, report setup. Go to file, report setup. Under the report setup, you just need to add job information. Apart from that, you need to add the picture.